In this video, we're going to learn how to find the trig functions for any angle on the Cartesian plane. So to be able to do this, we're going to look at a visual. Here we have an initial side and a terminal side for an angle, labeled theta, and we're going to put a ordered pair, a point, on the terminal side of the angle here, and we're going to label it x comma y. Now what we can do with this ordered pair is create a right triangle out of it. So we could say that the distance from the origin of the Cartesian plane here to the ordered pair x comma y, we're going to call that r, and then that the x value is just the distance from the origin to the point right underneath the ordered pair, and then we have y, which is the vertical component of the triangle, and we can label that. Now we've created a right triangle, and we also know Pythagorean theorem, so we can use Pythagorean theorem to figure out some lengths for this particular triangle. So we can plug in what we know. We used to have a squared plus b squared equal to c squared. Now we're going to have x squared plus y squared equal to r squared. Well, let's solve for r. To do that, we can square root both sides. Now we have the little formula. X squared plus y squared, take the square root of it, is going to equal the distance of r. And we can use that formula. Again, if we're given an x and a y, we could go ahead and plug in those values and figure out what the r value is. But what this is going to give us is now, can we find the basic trig functions of this triangle? So let's start with the sine. What is the sine of this angle? Well, we have to remember SOHCAHTOA. What's the opposite and the hypotenuse of this triangle? Well, the opposite would be the y value. The hypotenuse is r. So then the sine of this angle would be y over r. Moving on to the next trig function. What is cosine? Again, SOHCAHTOA. What's the adjacent side to the angle? Well, it happens to be x, and the hypotenuse r, so the cosine of our angle would be x over r. And the last trig function, tangent, which is opposite over the adjacent. Here is my opposite, here's my adjacent, so tangent would be y over x. But there also happens to be three more trig functions, and these are called the reciprocal trig functions. So starting with the reciprocal trig function of sine, which is cosecant. Reciprocal means to flip the fraction, so it's going to be r over y. We have secant, the reciprocal function of cosine, which is r over x, and then cotangent, the reciprocal function of tangent, which is x over y. So we can use a point in the Cartesian plane, create a right triangle, and we can find the trig function, or the trig ratio, for all angles. Okay, let's try an example here. Can we find the value of the 6 trig functions if we're given the ordered pair 9, negative 12, and on the point of the terminal side of the angle and in standard form? So let's look again at the visual here. If I were to plot the point 9, negative 12, we're in the fourth quadrant, but I have the horizontal component of the triangle, I have the vertical component of the triangle. What I do not know is my variable r. So again, remind ourselves, what do we know? We know that the x is the 9. We know that the y is the negative 12. Let's plug in what we know to the Pythagorean theorem, which is 9 squared plus negative 12 squared equal to r squared. Did a little bit of simplification. 9 squared plus 12 squared gives us 225 square root, both sides. 225 happens to be a perfect square. Now we know the r value to give us 15. We've got the 3 main pieces we need to use to find those trig functions. So let's go in and find those 6. Let's start with the sine value. Sine is y over r, so my y value is negative 12. The r is 15, so we got negative 12 over 15. And any time that we have a fraction we want to look to simplify, this would simplify to negative 4/5. Cosine, that is the x over the r. So we will have 9 over 15. Simplify the fraction. That gives us 3/5. Tangent, the y over the x. Or in other words, negative 12 over 9. Again, simplifying the fraction, that will give us negative 4/3. And then we go into the reciprocal one. So the reciprocal trig function of sine is cosecant. We'll take that negative 12 over 15 and flip it to 15 over negative 12. And that answer will give us negative 5/4. The reciprocal trig function of cosine is secant. So taking the 9/5, we flip it to 15 over 9. Therefore, the secant of this triangle is 5/3. And then cotangent, that's the reciprocal trig function of tangent. So that will go to 9 negative 12ths, or in other words, negative 3/4. So we have the trig ratios for all 6 trig functions for this ordered pair in the fourth quadrant. Okay, let's take a look at a second example. Now we have the ordered pair -6, -2. We want to find those 6 trig functions. Again, let's take a look at the visual that we have here. If we plot the point -6, -2, we end up in the third quadrant. Again, we're going to have to find the r value. So we know that x is -6 and y is -2. Use the Pythagorean theorem to solve for the r value. Simplifying, -6 squared and -2 squared will add up to give us 40. And when we square root both sides, this time 40 is not a perfect square. So we need to figure out what is the largest perfect square that would go into 40. That happens to be 4. And the square root of 4 is 2. 4 times what will give us 40? That's 10. 10 is not perfect, so the simplified radical for the square root of 40 is 2 square root of 10. Now we have our r value, we have the x value, and we have the y value. Let's go in and find those trig functions. Again, starting with sine. Sine is the y over the r, or -2 over 2/10. We need to simplify and also rationalize this fraction because we do not like to have radicals on the bottom of our fraction. So I'll multiply both the top and the bottom by the square root of 10. Knowing fractions, we just multiply straight across. This will give us -2 square root of 10 over 2 times 10. We can cancel out the 2's. So the sine of this angle is negative square root of 10 over 10. Cosine, going with the x over the r value. We can cancel out from the -6 and the 2 while we're also rationalizing with the square root of 10 over square root of 10, which will give us -3 square root of 10 over 10. Tangent, the y over the x. Well, that's just -2 over -6, or in other words, 1/3. And this leads us to our reciprocal trig functions. Now, what I would encourage you to do here is go all the way back to the unsimplified version. Since this reciprocal of sine would be cosecant, we have this fraction right here, -2 over 2 root 10. So we can start with it. That gives us our radical on the top of the fraction. And then you'll see that the 2 and the -2 will cancel out, or this will give us negative square root of 10. Moving on to secant, that's the reciprocal trig function of cosine. So starting with the unsimplified fraction from cosine, let's go ahead and flip it. And then look at the fraction 2 over -6. We can cancel out a 2 from it. That will give us negative square root of 10 over 3. And then finally, the last one, the cotangent. That's the reciprocal of tangent. Flip the fraction. This time, -6 over -2 will give us positive 3. So there is how you can use the Pythagorean theorem and all the trig functions to find, you can use the x over the r, the y over the r, the y over the x, and the reciprocals to find the trig values for all points within the Cartesian plane.